Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of chain rule to solve these two word problems. So let's start with the one on the left side. So 50,000 liter tank can be drained in 30 minutes. The volume of water remaining in the tank after t minutes is V at t equals 50,000 parentheses 1 minus t over 30 square, where t is between 0 and 30 minutes. At what rate to the nearest whole number is the water flowing out of the tank when t equals 10? Now, one important thing to understand here is that we are given the function for the volume of water that remains in the tank after t minutes, and we have to find the rate at which the water is flowing out of the tank. So the first step here is to find the function for the water that is flowing out of the tank. Now the capacity of the tank is 50,000 liters, and the amount of volume that remains in the tank after t minutes is this 50,000 parentheses 1 minus t over 30 square. So that means the amount of water that has flowed out of the tank can be written using this function. So F at t equals 50,000. So that's the capacity of the tank minus the amount of water that remained in the tank after t minutes. So 50,000 parentheses 1 minus t over 30 square. So this is a very important we need to understand, because here we have to find the rate at which the water is flowing out. So first we need to find the function that represents the amount of water that has flowed out at a particular point in time. Now we can find the rate at which the water is flowing out at t equals 10. So that means we have to find the instantaneous rate of change, and for that we'll have to find the derivative of this f function. So we can use the chain rule to find the derivative of the function. So the prime of f at t equals, now the first term in this function is a constant, so the derivative of that term is 0, minus, now 50,000 is the coefficient of the second term, so it will just stay as it is. Now in the next part of the term, so we have to use chain rule, because this term has an inner function which is 1 minus t over 30, and then the outer function is the exponential function with exponent 2. So we start with the derivative of the outer function, and for that we'll have to use the power rule. So we'll move the exponent 2 to the front, and we'll subtract 1 from the exponent, times the derivative of the inner function. So the derivative of 1 is 0 because 1 is a constant, minus, then the derivative of t over 30 is just 1 over 30. Because 1 over 30 is the coefficient of that term. Now we can simplify this expression. So prime of f at t equals, so the 0 goes away, and then in the next part we have to multiply negative 50,000 by 2. So we get negative 100,000 times 1 minus t over 30, and the exponent is 1. So we don't have to write 1 as an exponent, and 0 minus 1 over 30 is negative 1 over 30. Now we have to find the rate at which the water is flowing out at 10, t equals 10. So in the next step we can sub in t as 10. So prime of f at 10 equals negative 100,000 times 1 minus 10 over 30 times negative 1 over 30. So prime of f at 10 equals, now we can multiply negative 100,000 by negative 1 over 30. So we'll get positive 10,000 over 3. So we can reduce this fraction by cancelling out one of the zeros. And then times, now 10 over 30 can be reduced to 1 over 3. So in the next step, so prime of 10 equals, so 10,000 over 3. Now 1 minus 1 over 3 is equal to 2 over 3. So now we can evaluate this expression. So prime of f at 10 equals, so I got 2222.22. Now, as per the problem, we have to find the rate to the nearest whole number. So we can round our answer to, so prime of f at 10 equals just 2222, and the unit will be liters per minute. So that's the rate at which the water is flowing out of the tank at t equals 10. So this should be the final answer for the first problem. Now we can analyze the second problem. So the function s at t equals t cube plus t square exponent half when t is greater than or equal to 0 represents the displacement s in meters of a particle moving along a straight line after t seconds, and then determine the velocity when t equals 3. So here we are given the position function or the displacement function for the particle, and we have to find the velocity function. So the first step is to find the derivative, because once we have the velocity function, then we can sub in t as 3 in that velocity function to find the value of the velocity at t equals 3. So v at t will be equal to the derivative of the displacement function here, or the position function, and now we have to find the derivative of this function. So for this expression we'll have to use the chain rule. Now for chain rule we have to identify the inner function and the outer function. So the inner function is t cubed plus t squared, and the outer function is the exponential function with exponent half. So we start with the derivative of the outer function, and for that we'll use the power rule. So we'll move the exponent to the front, times t cubed plus t squared, and now we'll subtract 1 from the exponent, and then times the derivative of the inner function, and that will be, so 3t squared, so we are using power rule, and then plus 2t. Now we can simplify this expression. So v at t equals half times t cubed plus t squared, and then exponent negative half, then times 3t squared plus 2t. Now we can move this t cube plus t squared term with negative exponent to the denominator to make the exponent positive. So we get 1 over 2 and then t cube plus t squared exponent 1 over 2 times 3t squared plus 2t. Now we can find the value of the velocity by subbing in t equals 3. So we get v at 3 equals, so 1 over 2 and then 3 cubed plus 3 squared and then exponent half times 3 times 3 squared plus 2 times 3. Now we can simplify this expression. So we had 3 equals, so 1 over, so 2, and in the parentheses, so 3 cube is 27 plus 3 square, which is 9, and exponent half. And then the other parentheses, we get 3 times 3 square. So 3 square is 9, and 3 times 9 is 27, plus 2 times 3, which is 6. Now in the next step, we can simplify it further. So it's 1 over 2 parentheses. So 27 plus 9 is 36, exponent half times 33. Now we can do the calculation here. So we had 3. Now 36 exponent half is the same as square root of 36, and we know that the square root of 36 is 6. So 2 times 6 and then times 33, which can be reduced to, we had 3 equals 33 over 12, which is equal to 2.75. And the unit will be meters per second, because the displacement is given in meters and the time is in seconds. So these are the steps you have to keep in mind to solve this type of problem. So since we are given the position function, we just have to find the derivative of the position function to get the velocity function, and then we sub in t equals 3 to get the velocity at t equals 3. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.